Welcome everyone to the, digital version of supply chain management course, this time module 3. We're going to start with a new topic that is called location decisions. Now the name might sound strange, but I hope that by the end of the session, this will become clearer to all of you. All right, so let us start. As usual, we have some learning goals, and I'm taking this inspiration from chapter 10 from Krajewski, which is my main textbook. You know that I'm using several books, but that is like the core book. In case that you have it, you might find this topic there. But in other books, you can also find the same topic. So the method that we're going to see has nothing to do with Krajewski alone. Mr. Krajewski didn't invent these methods. These are very well-known methods, very generic. And the idea is for you to learn the following goals, and these are the goals for the module. Goal number 1 is to identify the factors affecting location decisions. Because as maybe you have noticed, whenever decision on where to locate a factory or a warehouse or a university or even a McDonald's, it's not a random decision. You want to make the best decision. You might want to consider several factors like customers, like access to infrastructure, etc. So we have some methods for that. Another goal for you is to find a new facility. So that means finding a new location. Okay. Another method will deal with locating a facility within a supply chain network. These are more like heuristic rule of thumb methods. That is not in this session yet. That will be the next one, and that will be explained by me later on. And of course, comparing sites. We have different options where to invest. Suppose that we want to rent a warehouse. All right, so how can we evaluate these sites? So there are different methods, and some of these are not really sophisticated. They can be like what they call factor rating matrix, which is just identifying the critical success factors and scoring them, and then just performing a very simple calculation of adding all the numbers, and voila, you have a winner. So there are many methods to solve these kind of questions. Today we're going to see just one. But let us start with a quick introduction. Facility location is a process. Now, I hope that by now the word process is clear to you. I mean, it's about transforming some kind of inputs. In this case, will be information, and the output will be a geographic site, a specific location. So there is a particular term which is called distribution centers that is highly used in the realm of logistics. These are the ones that you see if you're driving on the Autobahn, on the A40. You will see many of them on the side, and you see all these trucks parking there. And there are many activities performing inside. Sometimes there's even manufacturing, for example. Sometimes they're just breaking bulk. So on one side of the warehouse arrives a truck loaded with pallets of one single product, and this bulk gets broken, and really like literally by a knife, because they come with a plastic wrap, and then they just create smaller packages which will be later on redistributed with smaller trucks perhaps. But you can also have what they call fulfillment centers. This is what you see on Amazon. By the way, here in my town Kempen, where I am broadcasting, they are building an Amazon fulfillment center. It's a different type of warehouse. So nowadays, these are the two types. I haven't included this other definition. I'm really sorry for that, but it's important for you to know. Okay, so what are the dominant factors when locating a manufacturing facility in general? Well, we see here a map, and that's the US in case you cannot recognize. And here, in the middle of nowhere, and I really mean it, it's really the middle of nowhere. I mean, there are not really exciting cities. You don't want to make an exchange here. Huh? You don't want to go for a graduation project here. It's in the middle of what they call the Bible Belt, which is this region, of course, that is the East Coast. And here we have exciting West Coast and Seattle here, where grunge rock comes from. But here, in the middle of nowhere, FedEx has its main hub, they decided to place it here. And the question is, why here? Why not in fancy Atlantic City or New York or even Los Angeles? And then you might say, well, I mean, it makes more sense to go somewhere in the middle, because, you have to send all these planes all over the place. Now, why not here in the center? Well, if you have seen, what was the name of that story that about a girl and her dog Toto get trapped by a tornado? The Oz magician, right? The Wizard of Oz. Sorry, I'm translating from Spanish to English in my head. The Wizard of Oz. Now, this lady was where? Somewhere in Kansas. And it turns out that here, that's Kansas, all this region, this is called the plains. Hey, they're loaded with tornadoes. So can you imagine having a hub located there? Can you imagine having this hub located in a region where you have the failure of San Andres, which is like what creates all these earthquakes? I mean, or here on the north where you have these really terrible blizzards, snow. So obviously one of the decision factors has to do with the climate. So, but of course that is not the decision factor for everything. You might want to have other decision factors. And here is a list. You might want to be close to your markets. Let's say China. That's why you have a lot of manufacturing there. It's not just because it's cheap, it's because there's a huge market. I mean, BMW, all these brands, they have their manufacturing sites there, and they produce sometimes products or cars just dedicated to that market. You might also consider impact on the environment, because countries or states, they have different regulations, but also infrastructure, proximity to suppliers and resources. This is what Mr. Porter called economic clusters. There is a reason why northern Italy, Modena, I think, that's where Ferrari is having its facility, and right in front, that's Lamborghini, the strongest competitor. And southern Germany, you have all these car manufacturers, and the same, you can have Silicon Valley here in California, close to San Francisco, which, by the way, has the most educated people per capita. I mean, there are a lot of PhDs people, so they also want to be close to universities. So this is definitely a factor. You might want to be close to your parent company if that is needed because of the shipments. And of course, there is this very important utilities and taxes. And that's the reason why sometimes companies like Apple or Google, they set up their headquarters in Ireland, for instance, and then they pay taxes like €1 or so. So these are like their taxes strategy. Yeah, but this is just among others. It's just to show you the list of factors that you can at your disposal. Now, here's just a quick example. That is the auto industry, that is car manufacturing in the US. You can see how everybody's clustered here, except this one, number 4. Now, number 4 here in this picture, it is written General Motors Toyota. That is the so-called NUMMI plan. That was kind of an experiment in which General Motors and Toyota work together. Yeah, so competitors, they also cooperate. And they launched several cars. Now this plant is gone. It doesn't exist. But guess who owns that plant and who is manufacturing cars? Yeah, you thought about it, really? Well, I think you might know the answer. That is Tesla. Tesla is located here. You see, Tesla is located in the cluster of electronics and software, actually. That is the Silicon Valley. So that is just a fun fact, let's say. Oops, here is something with animation. Let me click them all. There are also some dominant factors in services. Let's have a close look to this picture. You see that there is a sign of McDonald's, and just next to it there is Burger King. And I don't know, maybe you have noticed the same, that you have these clusters of restaurants, sometimes when you're driving on the Autobahn or on the highway, or you have clusters of car dealers. Hey, you want to buy a new car, and then you go to this place, and then you have really Seat, next to Volvo, next to Volkswagen, next to the rest. And there is a reason for that. It has to do with what you read here. Clustering to reach critical mass. It means that you also get a benefit from your competitors by the fact that all together you can attract more customers. And then of course, let the customer decide which one is the winner, which one offers the best deal. Okay? And the similar example you might have on shopping malls. So shopping malls, you have a food court where all these restaurants are clustered together, and of course they have benefit. For example, the tables and chairs. They sit there and they all share these tables. It's not like one restaurant owns one or the other. They all share it. So that is just one of a dominant factor. So that will be this: proximity to customers, proximity to competition. Yeah. But of course, you might want to consider other aspects like transportation cost, proximity to markets, just like before with manufacturing, and of course site-specific factors. Because hey, if you're going to open a discotheque, you don't want to open that discotheque in the middle of a town with an average age of population of, I don't know, like 60 years old. You want to be near a university maybe. So in an exciting city like Düsseldorf. So these are like site-specific factors, which is almost like common sense that you need to consider. So these are just a quick list or examples, but obviously this is not complete. You can still continue this list. All right. Very quick example of a graduation project just to show you the relevance of this topic. I had a student once actually I had two students. They both work on the similar project, but on different timings. Yeah. And the project was about locating the so-called superchargers for Tesla. And then here you see the map of all these superchargers. But the idea was that you have to forecast the demand. So the Model 3 was coming in the pipeline. So based on the registrations of people who wanted to have that car, plus the customer densities of who owns these cars, well, these were the determinant factors to calculate where exactly you want to have. And of course, as you know by now, the capacity, how many cars you want to serve. So here we have the student had to calculate how to calculate average capacity, like number of cars per hour, for example. And then by means of a heat map, this person could identify where are located the most demand. So you can imagine a map like this in Germany, and then you have these heat maps, which, by the way, they go beyond borders. So just because here you have the border with Switzerland, it doesn't mean that the Swiss don't have Teslas. It doesn't mean that they can cross the border. Sometimes you have a lot of commuting. So this was taken into consideration. So very sophisticated and interesting project in a very interesting company. That was in Düsseldorf, by the way. I mean, just in case you're looking for a company, you can go there. All right, so we have a lot of methods for that. And again, here you have a list, and they are clustered by what they're trying to achieve. Today we're going to see center of gravity, or centroid, and that is for finding a new facility. Later on, we're going to review this, number 2 and number 3. Let me move on. Finding a new facility, the Centroid Method. Well, maybe you remember back in the days when you were going to high school, you had a class called physics. And then you learn all these formulas of how to calculate where a rock will land if you throw it with a certain force and with a certain degree or angle. And maybe you also learn about how to calculate the center of gravity between masses. Yeah. So picture like a car, an automobile. So you have a car, and there is a reason why sports cars, they are very low. And the reason it has to do with the center of gravity. You want to keep the weight as close as possible to the ground so that the car is not flying on the air with the high speeds or flipping over or whatever. But of course, that will change if you are talking about a 4x4 truck. So the formula, well, it looks like this. You have a center of mass. You have some variables, like in this case, mass 1 and mass 2 with different weights or sizes. And you also have some kind of distances, as you can see, highlighted by the variable x. And you might also argue that you have a reference line. So you can say, look, you have a mass 1, which is with a distance of x1, and I'm having a mass 2 with a distance of x2. And I need to find somewhere a location for the center of mass. And that will be this, x center of mass. And you have a formula. And honestly, I mean, you can do it for fun. If you like this, to do these things, you can calculate it with this formula. I mean, it's not really rocket science. You can find a lot of masses and maybe even experiment it yourself with an object. Okay. Now, you might be asking by now, why is this guy talking? Why is my teacher talking about this physics formula? You know, this is not physics. This is supply chain. Well, it turns out that the same logic applies when locating a warehouse. And of course, I mean, by now you have softwares and packages that do this job for you. And this is a screen of one of those that I found online for free, in which you will give them some locations as inputs. That will be the input data. You give them in terms of the mass, which could mean the capacity or the demand from this market. And you also, the software asks you about the location of these particular points. And then it will calculate the center of gravity. And in this case, very precisely, even with a street name like Senbergstraße 14a in Borken, Germany. Now I have no clue where that is, and maybe that is in the middle of nowhere. But this might not be the final solution, but this is what people call the first cut. The first cut. The first cut means it's kind of a suboptimal solution that later on you can tweak, you can polish it better based on other dominant factors. It's kind of a starting point, let's put it in this way. So maybe, it won't be here, our warehouse, maybe it will be somewhere here, or maybe it will be in Cologne, So it depends on these factors. But okay, this is just to show you that you have packages like this. But, sorry to tell you this, we're going to do this by hand. But it's not really complicated. It can be even fun, maybe for some of you. Okay, so, center of gravity method. It identifies and finds a location, and the location it is expressed as coordinates x and y, which is a good potential starting point, a first cut. The idea is to minimize distribution cost. That makes a lot of sense, no? You want to have a location that is the ideal in terms of cost. All right, so because we're talking about cost, we need to talk about value. And value is going to be determined by the sum of all transportation cost to and from that location. Now you see these letters here, because these are the name of the variables. That is a letter L. L from load, like loading, or that is a weight factor. That will be, in physics, that will be the M of mass. So this is our weighting factor. D, well, that's distance. I think is a very, kind of obvious. So that is a distance from a point to another point. Okay. Now, there are some assumptions, of course, and it's important that you keep them in mind. Here's a hint. Sometimes in the exam, you can have an open question like, hey, what are the assumptions behind this model? So keep this in mind. So the assumptions are the following. The costs are directly proportional to both distance and volume shipped. And revenue is assumed to be directly proportional to proximity to markets and the volume of goods shipped to those markets. So in short, what it means is that if you send an item from point A to point B and the distance is 10 kilometers, well, you will have a cost which will be the double if you send the same item to a distance of 5 kilometers away. And you know, in some cases might be the same, but in real life it's not the case, because you might argue that there are other factors like price of diesel that is always fluctuating. You might also say maybe the road, maybe the 10 kilometers is a very nice German autobahn, you know, completely flawless, whereas the 5 kilometers is like one of those roads in Peru that, you know, like they're going through stones and all sort of obstacles, and it takes forever to reach to that point. So we are ignoring all these things in this model. So it's kind of very basic, and that is the reason why it helps you to find a good potential starting point. Okay, so this is so far the theory. The formulas, please don't get scared. They look very weird at first sight, but I will explain them slowly, maybe not so slowly so that you're not sleeping behind your screen. But let's say that the goal is to find a center of gravity, and we're going to call the coordinates of center of gravity by means of X and Y, because we use coordinates, right? And because that is a special type of coordinates, that is the center of gravity, we're going to use this symbol that you see here, this asterisk. Okay, so let's go into the formula itself, and I'm going to go to one of them. I'm going to go to this one, and you see that it's exactly the same. So if you understand my explanation here, this will be clear also to you. Okay, so for determining center of gravity X, we need to do the following calculation. We need I represents the city or the locations that we want to consider. Remember, it is as if we have locations, sorry I cannot draw here, like spread all over the place, like in that example of Germany that I gave you. And then we need to find somewhere in the middle, right? So we need to have from every location, if we're shipping trucks, we need to know how much it needs to be cheap. That's the loading factor, that is the weight, that is kind of the importance factor. And we need to know that, and we also need to know the distance of that location. By doing this multiplication, that will be the value. We need to add everything depending on the number of locations that we have, and then we divide everything by the sum of all the loads that we need to ship on a given time. As if, hey, from that center of gravity we need to send 100,000 tons of cement. Okay, that sum will be this. Okay, so here I am trying to explain a formula. I know it's kind of abstract. If you got my explanation, great. If you didn't, no worries. With my example, I really hope it is going to become clear to you. Okay, so here's our example. A supplier to the electric utility industry produces power generators. The transportation costs are high. One market area includes the lower part of the Great Lakes region, that is in the US, by the way, and the upper portion of the southeastern region. More than 600,000 tons. This is more than, so it means that it's not exactly that. Are to be shipped to 8 major customer locations as shown below. So click. So here, 3, 4, 5, 6, 7, 8. These are the customer locations in all these cities. And here we have their respective amount of tons to be shipped. You already see some differences, right? You see that Akron, Ohio is demanding a lot. And you see the opposite with Three Rivers. What is that? Minnesota? Michigan, I guess. That's Michigan, that's Indiana, Kentucky, Wyoming, Virginia. So this is really the north, and you see how the variation of demand. You also have the location expressed in coordinates for all these cities. Now in this, of course, this is kind of a simple example from a textbook. In real life, well, that will be the altitude, latitude, and longitude, and these kind of things. This is what you will have instead. But you can always create your own coordinates. It doesn't matter as long as they are consistently applied to all the locations. So in this case, we have these coordinates. So the question is, what is the center of gravity for the electric utility supplier? Okay, so I'm having this box with the same data as a reference because we're going to run the calculations here. Let us start by calculating the center of gravity for coordinate x. Yeah, that was the formula. And we are going to calculate the upper part, the numerator, as they call it, which is this element. So how can we proceed? How would you proceed? Well, you would say, look, I represents the city. So that means that I'm going to have 8. I'm going to add up 8 items. And L, that's the weighting, that's the load. And here we have the load. And X is a distance factor, and we have a distance of X expressed in coordinates. So the calculation is as simple as, boom, what you see here. 5 times 7 plus 92 plus 8, and so on, which are the numbers that you see here. And that's the reason why I highlighted with red, because 5 tons are chipped from coordinate 7. That's what you see here. In the same matter, 92 are chipped, or have to be chipped, from coordinate 8. That's what you see here. And the rest, the same. So if you grab your calculator and you run these numbers, you end up with 7,504. And that is a numerator. Now we need to divide by the total of the amounts to be chipped. Now, if you remember well, the exercise said 600,000 tons. Or more specifically, more than 600,000 tons. Which means, if you add all these tons that have to be chipped, well, it's going to be, you would expect, more than 600,000 tons. In fact, it's 607,000 tons. I'm going to be honest with you guys. If you are like in the middle of an exam and you are running out of time, and you just don't have even the time to do this, if you plug here the 600,000 is also fine, because the final result won't be affected that much. And again, this is a first cut solution, right? It's not like every cent has to be declared. In this case, we are fine with that. But of course, if you place here 700 or 2 or whatever other number, then you are very off from the result. So in this case, we perform the calculation. We have a result, 12.4, and the same has to be done for y, the component y of the coordinates for the center of gravity. And I'm sure you should be able to perform that. So just, the tons remained the same. They are a constant. But now we are changing to coordinate y. So we end up with 5,572. Then we run the calculations. And voila, we have the centroid. That will be the x, that will be the y. So if we create a map and we put all these cities with those coordinates in that map, then we follow this advice of the centroid, and then you will see where that is exactly located in the map. That is the answer, ladies and gentlemen. There is an exercise 2, which is just about the same. It's about finding a central location for a service. And there are some traveling around from cities like New York, and some weighting factors or loading. In this case, the loading factor, look, it's not about tons of something to be chipped, but it's more like a frequency. You see, 20 occasions per year from New York City, 15 trips per year to Boston, 30 trips to New Orleans. So you already get the loading factor, but now it is expressed as frequencies. Coordinates are given for every city, and then what is the center of gravity for these 3 demand points? So normally in class, students perform this exercise, now you're going to perform it on your own. And I'm sure, I really hope that you can do it. Of course, if you have questions, you can ask me, but since now we are in this digital environment, why not having some kind of, I mean, you can also interact with your colleagues. Maybe your colleague can explain it better than me, you know? So here in class, I also advise the students to use this software as to find the exact location. But you know what, I just tried it just now and realized that for some reason the page is not working, so forget about this. I'm really sorry, I need to eliminate it. All right, having said that, thank you very much for your attention. I hope you could follow this lesson. It's not perfect, I know. I'm not a native speaker as well, so I am aware of that limitation. I hope you could follow me. I'm trying to do my best. Unfortunately, time is on top, so I have to do lots of recordings. So I cannot be like Steven Spielberg and, you know, editing the film so that it's perfect. That's the way I would like to have it. Thanks for your understanding, and let's see how we are going to cooperate. So for the time being, start with this, do this exercise, and if you want to have more exercises, don't be stopped. You can even find the Krajewski book, perhaps online. It's not me telling you that, and there are more exercises there, but you can find more from other books. Anyways, we stay in touch and we are always in contact. Thank you very much. Bye-bye.